Hello.
Hey, Luis.
Hello.
Hello.
Hello. The email with the invitation was in my spam folder, so I don't know if someone else will be having problems with this too.
Well, can you just maybe forward the link to people?
Yeah, I will send to the WhatsApp group.
Do you have the link?
Who is missing?
So let me just post the link into this chat, and then you can just send it to whoever needs it, okay?
Javier is missing.
I see in the mail list there is Mariona,
Mariana.
Ariana, Hamza.
Yeah. Will you send it, Luis?
Yeah.
So I haven't actually asked explicitly, but I'm assuming that most of you guys have some programming experience, so you've programmed with something like MATLAB or R before. Okay, good.
Yes.
I think MATLAB, no, most of us, except Hagen and Luis that are the animals.
Okay, very good.
I think some student, maybe Mariona, is a new student, and I don't know if she knows any programming language.
Okay, good. So I wanted to start with no prior knowledge. So we'll start with what is a variable, and then take it from there.
Okay.
So who is missing?
There's one more.
Okay.
I sent an email to everyone. So who is missing is Mariona, Ariana, Hamza, Nikolai.
Nikolai will not be able to join.
Okay, Florencia, that's it.
Okay, so I think we can start sooner as you want, Florian. But
Yeah, let's start. I mean, if people join a bit later, that'll be okay, no?
Yeah.
So, okay, good. So, hello everyone. Good to meet you guys on screen. Happy to teach you a little bit of Julia for the next 8 hours. So that's the plan. As you see behind me, that's Duomo di Milano. I'm in Milano this year on sabbatical, and that's the main church. Very nice to visit. You can actually walk on top. You can walk right here. You can go all the way up and all the way down. It's a pretty good walk. Okay, so in terms of organization, so given that this is a Zoom thing, what would be really nice if you turn on your cameras, and not only because I like to see who I talk to, but also it's very good for me to know whether you're understanding stuff. If you understand stuff, do like this. If you don't understand, do like this, or even better, just speak up and ask the question. Okay, but it's very good to at least show some nodding every once in a while. Okay, so the way I wanted to do this today is first we'll start from 0. So we'll start right here in a browser like I do. I'll get rid of the Duomo in a second. Then we will install Julia, in case you haven't, but just so that we all start from the same page. And then we'll install the text editor, and then we'll start introducing the language. Okay. And again, any question at all times, just speak up and ask the question. We're sufficiently few that shouldn't be an issue. Okay, so I'll start. Okay, I'll get rid of the Duomo and I'll go to. So now I want to do some research, and I want to choose a new language. And I heard of this new thing, Julia language. It's actually without the www. It's julialang.org. And I go there, and you end up at this website, which I actually recommend you have a look at. It's a very good website. It tells you a little bit about the language. Here's the documentation, very important. That's the manual, basically. It's very well done, so you should always come back to this place and search for stuff. What else is there? There's downloads. We'll go there in due course. There's a blog with news, and that's also very informative. What's interesting for you guys, I think, is the Learn button here. If you click on Learn, you will go to a set of tutorials and workshops like this one, maybe a bit better done even than this one, and so on. And so anyway, just explore this site a little bit. It's a very well done site. We'll go to download, because you want to download the program. I click here, and it says download Julia, and you see that the current release is 1.72. Okay, February 22nd, so that's the one we want to get. And then you will be able to choose your OS. Okay, you have a Windows computer. You have to choose whether you have a 64-bit or 32-bit system. You download the corresponding one. Linux, the corresponding binaries are here. I have a Mac computer, and I have one of those, x86. It's going to be older ones, so I would click here. Okay, so I'll click here. It downloads this thing. I'll say save file. I'll save it to my computer, and then once that's done, I will just install it as I used to. Okay, so I'll double click. I won't do it now because I already did it, but you should do it and install this, and then you will have Julia on your computer. Okay, so that's great. But now, how do we actually run this thing? Okay, so that's the next question. And so let's try to attack that. So you install it onto your computer. If I install a program on my computer, it goes into applications. All right, let's go to that. So that's my file explorer. I have a thing here, applications. So you have to, where that is on your computer. Okay, so here are all of my programs. And one of those programs is now called Julia. It has the version number there, Julia 1.7. So that's the one I just installed. And I will just double click on it, and it will run. It will bring up a little window, and it's going to look like that. Okay. And so hopefully that works for every one of you. Maybe the first time you have to say, yes, this is a safe application, or give some feedback. But yeah, hopefully that should just work out of the box. Okay. And then you can close it. Let's just close it. I'll just shut it down like this. Okay, because I want to show you something else. I want to be able to start this program from the command line.
So wait a second. Can you show again how it looks, Julia, when you open it, please?
Yes.
Sorry.
It has to look like this. Okay. So for you, if you install it today, we'll say 1.72, because you will install it.
Okay, it looks a bit different because it's black and things like that, but
yeah. Okay.
it's okay. Yeah,
that's okay. If it's black, that's going to be the background of your terminal. So that's tastes. If you like black, then that's going to be black. You can change it. Okay, so you see what I just did, by the way. So I open the terminal. That thing here is called a terminal. It's where you can issue commands. It's the command line of your computer. Everybody has one. I hope you can find it. If you're a Windows user, you have to go to, on the left bottom, start, and then there's somewhere there's this command line, and you go there. So what I just did, I just typed Julia, so because I want to be able to start this program from wherever I am in the file system. Because right now, for example, I'm here, which is my home directory. Let me make this a little bit bigger. Okay, so how do you do that? Well, that's pretty easy. Here on this site where you installed it, there's a help next to each program. Okay, let me click on the help for the Mac, which is my computer. So here it says, well, here's how you do it. You download this, and you can then double click on this icon. Optional, add Julia to path. So that's what we just did. You can copy those commands here. You just like grab them all and paste them into your terminal. This will create what is called a symbolic link. LN is a link, S is symbolic. We'll make a link from the location of the Julia binary, which is here. That's where I just found it in my file browser, into a location that is on my path, such that then I can just open it on the path. Okay, I can just open it by typing Julia. So it's going to know what it has to do when it sees Julia. If you have a Windows computer, that's slightly different, but not much. So you can do that here. These are the instructions, and you can add Julia to the path for different Windows versions. Okay, so you can look that up later on if that's interesting for you to do. I find this very, very helpful. I do it all the time. Okay, so that's how
why do we need that? Why don't we just click on Julia and that's it?
Yeah, so you can always do that. The reason why I like that is, I think we will see that later on. When we work on different research projects, they are somewhere on my computer, right? Oh my God, so this is too much. So let me go into here. Why can I just not see the, how does that work? Tree, help. I just want to see the directories. List directories only. Yeah, that's what I thought I did. So suppose I want to work on our paper. So our paper is, I have a paper with Mark. So I'll be very careful not to bitch about my co-authors in here. So the code for our paper is in a folder. It's this is my root, and so it's in .julia dev for development and land use. That's the title of the paper. So it's here. Okay, so let me now run this tree thing. This is what the code looks like for this paper. Oh, there's a bunch of stuff, but anyway, the Julia code will be somewhere here. Okay, so this is source, this is Julia. So if I'm in this location, I want to start Julia right there, because if I start it right there, we'll be able to maintain an environment of packages that is safe. Okay, so I know exactly which versions of packages I can use in order to run that particular project. Okay, that's a bit far apart for us right now, but that is going to be the main reason. So the main reason is that you can navigate into your file system to a certain location, and you want to start Julia right there. You know, you maybe see that at some point this may be useful. For now, that's not the main thing. Okay.
Julian, Florian, the same.
Yes.
We could do the same by entering Julia and then changing the directory inside Julia.
You could do exactly the same. Okay. Exactly the same. Okay. So if you double click on Julia, you will then have. We'll see that later on. Actually, we'll do an exercise on exactly that. Okay, very good. So that was the first part, install Julia. That's kind of very fundamental. Second part, we want to have an environment to use it. Okay, so we've just seen the little program, and we'll use that, the little terminal, but there's going to be nicer environments. So we want to have one of those environments, and a very good one is called VS Code. VS Code, for Visual Studio Code, is the editor of Microsoft. Visual Studio Code. Okay, so here we go. That's this code.visualstudio.com. You click on this, and you want to download the program for your OS. So for me, it says he knows that I'm a Mac, so he offers me that. So I would download this. Okay, so I'm not going to click on it because I did it already. download it and you start it just like the other program. It's going to bring up this this window, which I'll show you now. So if I type VS Code, it's going to bring up this window, and it's going to look like this when we start. Okay. So I'll just wait until everybody installed that. And then if you just give me a sign that you installed it when you're done with that. Okay, everybody good with this? Yeah?
I'm about to finish.
Okay, good. So what is VS Code? Is just a code editor, like you know, Notepad, or there's thousands, Vim or Sublime, whatever. VS Code is a very good one, so you should use it for as much as you can. It has very good integrations with a bunch of languages. Python, for example, you can have a full Python development environment here. You should get accustomed to this, so go on this, get started with VS Code and have a look through it. It's very well done and it's nice. And you know, there's some things to learn about the editor. It's very intuitive, but anyway. What we'll do, we'll add, we'll click here on the left where it says extensions. We'll click on that and it will bring up here, this is the list of extensions that you can install into this editor. And so we want to have the Julia. If you type Julia, it's going to bring that up. Well, we basically want this one, okay? Julia language support, so it's the first one. So for me, it's already, you will click install here. For me, it says uninstall because I already have it installed. So you just click here and it will install the VS Code extension for Julia. Okay, and then that should be it. Once that's done, you can close this and you can go here where it says Explorer. Okay, and it will tell you that you have not opened the folder yet, you have not opened the file yet. Okay, so it's all fine. So once you've installed that, you can open a folder like it says here. Command O for me. For you, if you're on Windows, it tells you a different shortcut. Just do that. So Shift O and create maybe a new folder somewhere. So I would, you know, maybe for this workshop that would be useful. Just here, maybe, I don't know where you want to do that, somewhere on, so I'll just do it, this is my home directory, and I'll just create a new folder here, which I'll call bootcamp. Okay, and I create this, and it's an empty folder, and I'll open it now. Okay, open it, and the VS Code switches into that folder. This is the content of bootcamp, it's empty, as we said, and that's it. Now you can use it to write and run code. Okay, and well, let's try and run a Julia file. Let's do a new file. Here it says new file. You click on this. It says what kind of file do you want? Yeah, a text file is fine. So let's just do this one. Text file built in. And it's going to be an empty file. Okay, now it says select the language or save it. So we can just save it right away. I'll save it and I'll just call it just something like test.jl. .jl is the Julia language extension. Julia file editor called test.jl. And you can see that something should happen down here. It should switch into Julia mode. It should say, I'm starting the Julia language server. And okay, so that's some activity that's going on, but then you're basically good to go. So now you can evaluate code if you have this here. You would say 1 + 1. And you could hit Shift Enter. That will bring up the Julia terminal down here. You see Julia is starting now. It says it's pre-compiling something, a package, that it needs to run this. And then it says 1 + 1 is 2. Okay, so for me, it seems to work, the whole thing. So let's see if it works for each of you to start.
I'm not getting the 2. So What do you say you press? The
Me
shift?
neither. I'm not getting the 2 either.
Which tool do you mean?
The result.
Ah, okay, well, just wait a second. Just maybe it's still,
Oh no, now there is a 2 months. I think
Yeah.
it's low.
it's,
I think I pressed too many times.
yeah, don't worry, it will come. It's just, it needs to pre-compile this package and then it will show you that 1 and 1 is 2. Okay, good. So that's the basics. So we will use this. Basically, what I would like for the workshop for you guys to do is to have this thing open and down here in the console. So this, what you see here, this is the Julia console. The same thing that you open. That's the same thing as when you run your usual thing and you say Julia. Okay, so that thing here is the same as that thing. Okay, it's like, so as a MATLAB user, you're not so used to that, but as an R user or as a Python user, you will be very used to that. So you have the, let's say the engine, then you can stick that into different environments. Okay, so and here, there's just one Julia on your computer. It's the one you installed and downloaded. And this one you can stick in 2 different environments. And so here it runs in the bottom of our VS Code instance, and here it runs standalone on its own, just in the terminal. Okay. And so I said, what I would like you to do is either have this one open or the terminal, and just because I'll show you obviously a bunch of code, and you should just go and type along with me. Okay. Everything I show you, I would like you to try out as well. Okay. And so maybe if you do it in an editor, it's good because then you have all the commands there. And you don't have to remember by heart. You can just go back to this file and look at this. You can obviously also make comments here. So you can say, write a comment here. This was our first command. And you can save it. And so next time you come back to, what we did here and what it was good for. Okay, good. So that's it. We're almost done with setup, so just bear with me. There's a couple of things we need to figure out to run this smoothly. The next thing I want you to do inside VS Code is to open the command palette. At the command palette, you open this with Shift Command P. If you press those keys together, Shift Command P, you bring up this thing here. If not, you can go to the little cogwheel down there and it says Command Palette. If you don't like shortcuts, you can always click here.
But what is the command key?
In Windows, it's Control-Shift-P.
Yeah, just click here. Mark, just click here, left bottom, and you will see the shortcut next to it. Bottom left on the cogwheel. You see? It's the first thing. Yeah, command palette. Okay, so now you see it open here. It's the command palette. It's all the commands you have in VS Code, so you can issue commands. Okay, there's a bunch of cool things. Oh, by the way, the LaTeX workshop is amazing. So if you work with LaTeX, try that out. It's very nice to do. It updates in real time. It's really nice. But what we'll do, we'll type shell command, and we want to do the first thing: install code command in path. Okay, so if you see that, just hit enter. And it's going to say shell command successfully installed in path. Great. Because later on, we want to use this editor to bring up source code of Julia. Okay, we want this to jump up, and if we tell it to do so. Okay.
Sorry, I think I'm lost.
Okay, no worries.
So about this palette, command palette,
yeah,
I'm going there, I'm clicking, and it's like nothing happens. Can be.
Yes, you get the same thing like me. You get
you get this thing. Okay, yeah. And then you write here shell.
You're right. You start writing shell.
I don't get any shell command.
Me neither, Florian. I don't see any shell.
Okay, interesting. So, okay, so let's just figure this out. The other one, everybody else gets this?
No, me neither.
Okay, so who has a Windows computer?
I do.
I do too.
Me too.
Okay, but Vagan, it works for him?
No.
Okay, for you neither. So everybody who has a Windows can't do that? Okay, I see. I didn't know that. Okay, well then it seems that doesn't work on Windows. but that's fine. Don't worry about it. It's just an extra thing that we could do. But okay, let's forget about it.
Sorry, can you say again what is this for?
So this is going to be for, you'll see that later on. Okay, I'll show you. But basically, what you can do now, it's the same story as with the Julia command. You can now write code, and it jumps up and it starts the editor from the command line. Okay.
Okay.
You'll see that later on. It's going to be very nice because you can. Well, you'll see it. Don't worry. Just bear with me. Okay. Good. So we've done that. Okay. Next thing we'll do, we'll customize how Julia starts up. And so when Julia starts up, it like many languages do, you can customize it to some degree. You can tell it what it should look like and what functions it should execute at the start. But you know, now that I think about it, all of these issues with the Windows computers, let's just forget about that. Okay, it doesn't really matter.
Yeah, no, I think for Windows it is installed by default in the path.
Okay, awesome.
Yeah.
Fantastic. So we don't even need that. Okay, great. Okay, so I mean, then we can try. So there is a file. So I need you now to go to your command line.
I never opened this, Florian. So what is this terminal thing? How do I do this terminal thing? I've never.
How do you do this on Windows? You guys must know. So
just go to the start and there is the program installed. You go there. No, Mark, it's gonna be Julia 172. Just click there.
No, but this one, how can you do this? How can you go to the command line? How can you do stuff like
Yeah, you press the Windows key and then write CMD.
Yeah, command, exactly. That's the thing.
CMD?
Yes.
Where?
Press enter.
Símbolo del
press the
sistema.
Windows button, and then when that window appears, you write CMD, and it should appear the icon, and you press enter.
I get something that says users/Martenier. Is that the thing?
Yeah, Mark.
Maybe Rafa. Oh yeah.
Thanks. I've never used it.
Yeah. So I just want to show you a file location, which is kind of important, where Julia stores all of the, let's call it system files, so the stuff it needs to work. Okay, so if I'm, you know, on your computer, you have your home directory, so I'm there now. If I type pwd, it says that's where you are, present working directory. Okay, so it's here. For you, it's going to be at the same directory, so you have to know what your home directory is. From there, you can go to a directory that's called .julia.
Florian, how do I leave Julia in the terminal?
You just close the terminal, just close it.
Okay.
Or you type exit, exactly. Exit is the command that closes. Yeah. Exit as a function with 2 brackets. Okay, so you don't need the terminal, Mark. If you don't like this thing, you have to find it in your file browser. But in the file browser, it's usually a bit of an issue to find hidden files. And so I would know how to do it on a Mac, but on Windows, the .dot files are not so easily findable. I don't know how that works. So for me, I put a shortcut here that I can always go there, but I'm not sure how that works on Windows. So you have to go to the location home.julia. That's where you have to go. So go to that path somehow on your computer. I'll leave you to it. And then if you look into this, so I would type ls for list, or I just go here, it's gonna look nicer. So these files here, what you see on my left, they are kind of the stuff that Julia needs to run, and that it, you know.
The Windows guys, how do I go to this Julia thing? I mean, I say Julia is not recognized as an internal or external command. Is it because I'm in the wrong?
Have you tried cd.julia? cd space.julia?
Yeah, Mark, just like I did it, cd.julia. cd means change directory.
Okay.
Yeah, it works.
It works, but now I don't see any of your stuff. How do I?
Yeah, type ls.
ls doesn't work.
Oh, great. Oh, God, this is. Okay,
Luis, maybe Luis knows.
We need a
Okay.
translator from Mac.
I don't remember.
Yeah, so
Absolutely no.
no, this terminal stuff on Windows is a nightmare. So you just have to find it on in your file browser somehow. There has to be a way. Okay, so and for now, don't worry about it. Okay, we'll postpone it. You can look for this yourself. It is there. You just have to find it. I don't know how you find a dot file in Windows.
In Windows, you can use the dir command instead of ls.
dir.
Dir. There we go. So exactly. So type dir. Once you're there, for me it doesn't work. But you type dir and it's going to show you the contents of this. So these are all folders. And let's just look at my screen. I think it's nicer. So in these folders, you have these kind of system files that Julia needs. And so what I wanted to show you here is a thing called config here for configuration. Okay, configuration. And there's one file that we want to look at. It's called startup, which is going to have the kind of instructions for Julia when it starts up. What does it have to do? That's what I wanted to show you. And I wanted to just highlight to you that you could, let me just pull that into here. So this is what my startup file looks like. These things here at the beginning are to make the shell mode in the REPL sticky. That doesn't mean anything to you now. That's fine. So just forget about it. I'll just give you that code later if you want to do that. What I want you to know is this one. So I set the Julia editor to code. Okay, so env is a variable. It's an environment variable. The name is Julia editor, and I set it to code such that when I call the editor from inside Julia, it's going to use VS Code. Okay, it's just an aside. You don't have to do this now. I just want you, because then otherwise later on I'll use it. And so now I want you to know how that worked. Okay, I'll give you the code and you can place that code into the startup file later on if you want to. Okay. Okay, let's get rid of this and let's try to make some progress. Okay, so we've done how to run Julia. Well, how to run Julia as a standalone app. We've done that. We go to our applications. Let me just do it again. Applications. Search for Julia. Double click, and here it is. Julia. Great. Run Julia inside VS Code. Okay, we've done that. So you have VS Code here. You open a Julia file, or you can also do this manually without opening a Julia file. So let me kill this. You can open the command palette again. So Shift Command P, and you can type start writing Julia, and it brings up all the Julia commands that it knows now. And the first one is start REPL, and you click on that, and it starts Julia down here. Okay, and then you can start typing 1 + 1. Okay, and it gives you 2. You can see here that those were 2 different modes already that I showed you. So one mode is typing and getting results right here. One is having the file there and in line getting the result. Okay, so that was, you remember the testing. If you do Shift Enter, so you get that with evaluate with Shift Enter. It says, it gives you the result here, you see? It says it's 2 in line. It doesn't print it there, it shows it here. It does print it down here, but it's a bit weird sometimes. So here, if you evaluate it, you get the result in line next to the command. Okay. Again, if I do it down here, I get it right into the console. Nothing happens up there. So you can do the 2 things at the same time. Okay, those are the 2 main ways to do it. Either in the terminal or in VS Code, you can run Julia. Okay, we've done that. All right, now let me go to my. Well, I'll just use this one. That's okay. So I'll just use this one and make this a bit bigger. So I used this word already several times, REPL, and no one asked me what it is. So who knows what REPL means? Okay, you guys need to ask. There's no way that this is going to work. So REPL, you write it like this. REPL is short for read, evaluate, print, loop. REPL. Okay, and so that's basically what a console does. MATLAB is a REPL, R is a REPL. They're all REPLs. So what does it mean? It reads from you, so it reads what you said. So it reads 1 + 1. Right? It's going to read that. It's going to evaluate it. And it's going to print it. Okay, so that's just what we think of usually as a console. For you that's totally normal, but you have to appreciate that there's many languages where you don't have a REPL, right? Like even in C++ or in Fortran, you don't see what you do, yeah, which is kind of very annoying. So you have to, you miss the loop part of this thing, because here you can do it over and over again. Of course, as you well know, you do something, you see it's wrong, you change it, and you change it as long as it's wrong, and then it's right. So this workflow is kind of missing in more traditional languages and compiled languages. Okay, so let's get our hands a little bit dirty here. Let's try to work a bit with this REPL. So the REPL itself, the thing where it says in green Julia, has a couple of modes. Okay, and so this is the normal command mode, let's call it like that. So I can type 1+1 and it will immediately evaluate and print back the thing. Very important is the help mode. The help mode you get into when you type a question mark. So just type a question mark, everyone. And you will see that the prompt jumps into help. Okay. And so now you're in the help mode and you can just ask for help. So you either, have a function name that you want to investigate or something. So let's look for the help file of the max function. Everybody look for the help file of max. So you just type max here and hit enter. Okay. And you see that it brings back the help file of max. Okay, so what does it say? Max x, y, ... Return the maximum of the arguments with respect to is less. Also the maximum function to take the maximum element of a collection. Okay, and then there's an example. All right, so far so good. That's what it is. So the example already shows you that the signature of the function has two arguments, x, y, and the dots. And the example has 3 arguments. Okay, so the dots here stand for more arguments. So you can put more than 2 arguments. For example, the guy puts 3. Okay, so let's try to do something. Let's find the maximum over. So let's find maximum over 3, 5, 10. So everybody try and do that. Okay, so what's the maximum over 3, 5, and 10? Who can tell me?
10.
All right, excellent. See, it means it works. Okay, so max 3, 5, 10 is 10. Okay, fantastic. Okay, good. All right, let's go on. So this guy said here, with respect to is less. So let's look for something else. So let's go again into help mode. And
just a second.
Sure.
If Florian, I wrote it in the text in this file.
Yeah.
And then the answer, am I supposed to get it or not?
I don't know. Let's try. So max.
Because I'm not getting it.
You have to now do something. If you do nothing, nothing happens.
I press enter, but
yeah, if you press enter, it goes into the next line.
Okay. Is the
so,
shift?
You see, evaluate with shift enter. So let me just put that here.
Okay, now
you have to get used to it a little bit. Okay, so you do shift enter.
Yes.
And evaluate it. It says 10, and also it prints 10 down there.
Okay.
Very good. Very good. Okay, next thing we want to find about is the help for if else. All right, that's another function we want to find out. So let's see if else. What is this function? So type help.
Florian, should we ask what is less?
You should ask that. Yes, absolutely. So
I thought we were going to talk about it.
Yeah, so we can talk about this, but let's go first into if else. So he says,
sure.
Return the maximum of the arguments with respect to is less. So he says he's going to consider maximum with respect to is less. So he has an ordering that's going to be called is less. Okay, so it's going to look for, if he orders the elements, what's the last element? What's the biggest one? Which is exactly what we think when we say maximum, right? So this is all a bit weird now, because what else could it be? But you will see that we can define very weird data types in Julia, things that are not just numbers. And so, you just have to bear with me. it will happen. And then at some point, we will be able to define max over this certain weird data type. Okay, and at that point, we have to define what does it actually mean, max. So we have to define an ordering of some sort. Okay, so that's why it says here, by default, this thing uses is less. So it says is 3 5 then less, is 5 less than 10, and so on. But let's go to if else. Let's go to if else and look at this first, because we'll get to the bottom of this. So the function if else, well, it does what you would suspect. It says there's a certain condition. If else, if it's true, it does one thing. If it's false, it does the other thing. Okay, so look at the example. It says if else 1 is greater than 2. If that's true, do return 1, otherwise return 2. What does it return? If else 1 greater than 2. So that's not true, that's wrong. Let me just try this out. Okay, 1 greater than 2 is false. So this is going to be false. So it has to return the second element. It's going to return a 2. Okay, I understand. Now, why do I want to show you this?
Florian, just
Yes.
can I ask before you move on?
Sure.
In the help for the max function, you have just x and y, so it doesn't define the argument, what the argument is. But in the if else, it defines the argument, right? Because it says it's a Boolean, which you need to put first.
Yes.
But then the x and y doesn't have a type.
Yes.
Does that mean that the function can take any type of thing that you put? Or
yes, exactly. Very good question. I mean, you're way ahead here, but that's exactly where you want to go. So I want you to spot these things, guys. Okay, so the if else function is weird. We'll talk about functions. Okay, let's just go slow. But it's a very good point that here there's a weird thing here. It says condition : bool. Okay, so and Rafael pointed out, it specifies the data type that goes into that argument. So the first argument to if else has to be a bool. A bool is true false, as you well know. Whereas the x and the y, there's no : okay, which means it could be anything. Okay, so we're free to put there whatever we want because we decide what the thing returns. But I need to slow you down. Okay, you're too fast. We'll get there. Okay, very good. Okay, we saw the if else thing now. If else is pretty easy. What I want you to do now, though, and this is kind of very Julia, we want to know how the max function looks like. We want to know what it does. So now we know how to use it. Okay, so that it's pretty easy. But how does it actually look like? What does it work? How does it work? How does Julia compute the max over 3 and 2? And for that purpose, we have the edit macro. Just say edit. Everything with in a start is a macro in Julia. Edit max 3 5. So this is my function call, and I'm going to call this macro before it, and I hit enter. And it's going to jump into the Julia source file at line 479, where the max function is defined. Okay, so this is only going to work for you if you have a valid editor defined, as I did before. Otherwise, you have to do that. You remember the startup file, environment variable editor, and so on. So it's just going to open some editor for you now, hopefully anything. Okay, let's quickly look at this. So how does it do that? Max for 2 arguments, 3 and 5. Okay, this is what it is. It's this line here. It says max x and y. If else y is less than x, otherwise y. Okay. Why do I show you this? I want to show you this because that's very easy for you to understand. If you want to know how does the max function look like, you can just look at it. And very differently to some languages, even R or Python, that's a Julia function. You see, that's Julia code. It uses the if-else function, which is a Julia function, to compute that. There's no underbelly of the language, which is written in C, where you have to understand, how do you, do stuff in C. So whenever you have questions about the source code, you just do edit and you call the function. It's going to take you to the point where the function is defined. Okay, so this is the file promotion.jl. You can see this is the path that goes there. It's inside my Julia, and somewhere it's in the base of Julia, and so on. Okay, so that's where it is. Just a little demonstration of how you can look at source code with this.
Sorry, do you know maybe an alternative for this? Because for me at least it doesn't work, that edit.
Yes, so that has to be that you have no editor defined, as
Okay.
we said before. So you can easily remedy that by putting the name of the editor into your startup file. Then it will work. I'll send you this little startup file and you can place it into the right location, and then next time it should work. Okay, you just need an editor that you can start from the command line, as I just did with code. Okay.
Okay, thanks.
Okay, good. So that's pretty good already. Okay, we know how to compute max over 3 numbers. I think we made a lot of progress. Let's do something else now. Let's create a new file here. So here's my test file. I'll close that. You can just do command new. That makes a new file, or you go to to file, and when it's going to say new file, it gets you a new file. And let's save it as a Julia file, such that this is sorted. So I'll save it as hello.jl. Okay, and so again, so there's nothing in it, and I want to use. Well, obviously, what do I want to do? I want to print something. Okay, so there's a function that's called print. You see, this is nice with VS Code. If I start typing here, it starts bringing up relevant function names. Okay, so I want to use the function println. Println. If you go here, it's going to show you the help file for this. Okay, what does it do? Println. Print using print x followed by a new line. If IO is not supplied, it prints to standard out. Standard out is your screen. Okay, so that's how it works. Example, println hello, comma world. Okay, we want to do exactly that. All right, so println, get rid of that. We want to do hello world. Okay, and I want to save this. So I do command S, it's saved. And now I don't want to run the line, I want to run the whole file. Okay, suppose there were a bunch of commands and I want to run them all in once. There's another nice shortcut, which is, so again, bring up the command palette, go here and do command palette, or do shift command P and do type Julia. And it's going to say the third thing says execute file in REPL. And there's a shortcut that you can memorize or not. But anyway, you just click on this and do this, and it runs the whole file and it prints the output here. Okay, so the output of this file is hello world. Okay, and so that's it. Okay, so you can now you know that you can collect many commands here. So this is like in Stata a do file, or in MATLAB some sort of script file. You can collect commands and run them all at once, and you all dump them into your. It's literally like copying and pasting here. It does exactly the same thing. Okay. Okay, good. All right, that's that. Final thing I want to show you, and then we'll move on to something a bit more fun, is, so we did the shortcut. I can also use a function that's called include. Include, and the file name. The file name here is hello.jl. So if I do that, the same thing is going to happen. It basically does the same thing as when I say run file up here. Okay, so include, if I do help include, there's a bunch of things, but basically include, you have to give it a path to a file name. Okay, and it's gonna just grab the file, this one, and just copy it into the REPL. Like here, you're just gonna say, okay, take all of that and run it. Okay, that's all you have to know in order to basically run code, either by typing it, by saving it in a file and going line by line through it, hitting Shift Enter each time. Or if you know that you get too lazy, then you just run the whole file with the relevant shortcut, which is this one, execute file in REPL, or using the include function to do the same thing. Okay. Everybody on board so far? Okay, good. So this was the slow part. And so now we'll get to we'll turn up the speed a little bit.
No,
And
don't
we'll
do that. Sorry.
Say it again.
You can do it slowly.
Okay, no, I go slow. I'll go slow. I'll go slow. Don't worry. Okay, good. So I have my little cheat sheet here on the left, as you could imagine, so that I don't say too much stupid stuff. Good. Oh yes. Oh, well, I see. Okay. There's one thing I want to tell you first, which here it says, what are packages? Okay, so we mentioned the word package before when I showed you this location on my computer where these packages will be stored. So what you've seen here so far, what you've done so far is called base Julia. It's what's the core of the language. It's what's built in, you know, basic operations, max, print, and so on and so forth. Then, like in many other languages, there's add-ons, and those things are called packages, which we can install. Okay, they're somewhere on the internet, and they're basically all on GitHub, which is a website where people store code, and you can install them from there. Now, these packages, they have a certain format, of course, so they're structured in a certain kind of way, and we can just use them. Okay, so they're very important. So now we'll do something. We'll create a file, and we want to install a new package. Yes, let's do that. So let's go to the distributions package. So let's open a browser. So the way you do this in Julia, you just know the name of the function of the package, distributions.jl, and you just search for that in Google. And you will see that, so here the first one, Julia stats distributions.jl. Let's click on this. It brings us here. And so what you see here is called a Git repository. So the website is github.com. In this window, you see the content of this repository. So that's all the stuff that's in it. And the only thing I want you to, well, of course, this is the README, so it's very important. It always takes you to the documentation. Hopefully there is some documentation. So if you click on doc stable, it takes you to the stable documentation. And there's a bunch of other things. So you, by all means, always look at that and look for the documentation. But what I wanted to show you here is an important file, which is this one, project.toml, which specifies what packages you need in order to run that particular package. Okay, so each package is going to have additional dependencies, most of them. Okay, they're going to use other packages themselves. And so if you click on this project thing, you see it's well, this one is kind of long, but it sees deps, the file, the thing deps tells you what do you need to run this. So these are other packages that you will need to run this package. Okay, I'm just telling you this because sometimes you see these weird files and you don't know what they are. So if you see a Julia package, the project.toml gives the exact specification of packages that you need in order to run that particular package. Okay, it's just information, nothing for you to do. What I want you to do though is install this package. Okay, so how do we install a package? All right, so let's create a file. How does it look like? Let's create a file. So where's VS Code? Bring it back. Okay, VS Code. Create a new file. So I'll do again Command N for new file, and you know, just give it a name. I don't know what. Save it as something. Save as package maybe, or distributions. Distributions.jl. Okay, good. All right, empty file. And so we want to use the distributions package now to do something. But first of all, we need to install it. How do we install it? It's very easy. Another mode of the REPL that I didn't tell you about yet is called the package mode. The package mode, you get into it with the closing square bracket. Closing square bracket, what is it? It's this guy here. Right? So type this thing down there. As soon as you type this, it switches into package mode. It gets blue. It says package, and it says, the first thing says something weird. It says at version 1.7. Okay. And so now you're what is called package mode. You can, for example, type help, and it's going to bring you the help for the package mode, right? Which has all of these commands that you can use to, okay, welcome to the package REPL mode, it says, and so on and so forth. Okay. So one important command is status. So let's just type status. Status brings you the status of this environment. So the 1.7 here in the beginning, that thing, that is the current environment that we're running Julia in. So 1.7 is my global environment, my overall environment that I can, if I start Julia, it just goes there. Okay, and so it's located at a certain, it's a file itself. It's located in this location, in environments, and that's it. It just has one package in it for me. It just has the Pluto package in it with a certain version point, so whatever, 0.17. Okay, that doesn't all matter, but now let's add a package to that. So let's add the distributions package. Very easy. You just type add distributions, and then you hit enter. You hit enter, and it's going to go online. It's going to go on to GitHub. It's going to download a list of packages, which is called a registry. And that's the first thing it does. Oh, and then it does a bunch of things. Look at what it all does. So let's just go slowly. So the first thing it says, okay, I'm going to update your environment. It says updating your project tunnel here. And what does it update? Well, it adds the distributions package. And then it does change another file, which is the manifest file, which has all of these little dependencies in it that we've just seen in this project tunnel. Okay, so these are all other packages that you need in order to run the distributions package. Okay, and then that's done. It has to do like this: pre-compile, successfully compiled, and that's it. Okay, let's type again status. Okay, status.
Forever for me.
It's going to take a little while. It's going to do some compilation, so just bear with it for a little while. You know, because it has to compile all of these things that are there. For me, most of them already were compiled, you see, so I had to do a little work here. But anyway, somebody will stop, and then you can again type status, and you will see that now you have this additional package, which is called distributions, a certain version. Okay. Okay, good. So now that's fine. That's all we needed. We can go back into the normal mode with backspace. Just type backspace, and it takes you back to Julia. And that's it. So now we're equipped with the distributions package. And now I want you to do a task. Okay, I want you to do first task is this one. I'm going to put it here that you can see it and read it. I'm supposed to read that. God. Okay. All right. There's two tasks. All right. Create a file. Okay, we did that. Create a file. Say you want to use the distributions package and create a normal distribution with this command here. All right, so let's go slowly. Then look at the help file for quantile, help quantile, and the help for PDF, and then compute the value of the PDF at the 95% quantile of your distribution name. All right, so now it's going to get a bit tricky. Okay, so now stuff is going to get real. So now we want to actually use that. So first thing, we want to use the package. Well, you use a package by saying using the name of the package. Okay, because you know, so let's just go slow. So I installed this distributions package now, and it has the function PDF in it. I tell you that. But if I type PDF now, it says I don't know what you mean. Julia has no PDF. Okay, that we don't know what that is. So it says not defined. All right. So I first need to kind of tell it. All right. Now you use the distributions package to know what the PDF is. All right. So the first thing you have to do, you write maybe in that file that you use later on. You write using distributions. Distributions. Here we go. Okay. And All right, so if you do that, just evaluate this line using distributions. And now if I try again PDF, okay, it says at least something. Okay, we'll see later on what that means, but it says, okay, there's something that's called PDF at least. All right, very good. So your task is to create a normal distribution with this command here. So, wow, what is this doing? So it says normal. So what is normal anyway? So what do we do when we don't know something, when we look at the help file, right? So you do help normal and you enter. It's going to bring back the help for the normal distribution out of the distributions package. Okay, so it tells you this thing, what is a normal distribution? There's 2 arguments, mu, sigma, and so on and so forth. Okay. Okay, good. So by typing this, you can create one of those things. So n is a normal 1 and 1.5. That would create a certain normal distribution. And it's going to look like this. Okay, good. Now the next thing, we want to look at the quantile function. So we look at the help for quantile. Help for quantile. Wow, there's a bunch of things. Look, there's all of these things. So quantile seems to be defined for many, many different things. You see, so quantile for an iterable, quantile for. So these are all different uses for that function. We'll talk about that later, what that means. There's another version. There's all of quantiles, and the last one you see is for univariate distribution. So that's the one we're looking for. So the quantile for a univariate distribution and the number q that is the quantile works like that. So pretty easy. So you would just say quantile. What's a univariate distribution? Well, our thing n is a univariate distribution. How do I know? We'll see that later on. But if I type of n, it says, okay, it's a normal distribution with a float stored inside. All right, fine. So if I do quantile n, and now I have to choose this number q, I want to have that at the 0.95 quantile. All right, 0.95. What is the 0.95 quantile of the normal distribution? Defined in this way, it's this number, 1.82. Okay, good. So that's almost the entire exercise. The final thing is you have to now evaluate this number and tell us the PDF of that. Okay, try to do that. Try to do that, and then we make a 5 minutes break.
So Florian, this finally finished. This adding the packet or whatever.
Yeah.
Then I have to do the backspace. Is it what you said?
Yeah, do backspace. You go back to green.
And then now I'm green.
And then you can do using distributions, and then you are able to use the functionality of the package.
That's what I did remember, using distribution.
Yeah.
So Florian, a variable type can be a distribution.
Exactly
in
right.
this language. Okay.
Exactly right. Exactly right. Okay, again, we're a bit jumping ahead because I just wanted to show you what it means to use a package. But indeed, the type of n, as we just wrote here, is, is a weird type, right? It's not something you would usually know as a type,
Yes.
An integer or a float and so on. You can see that that's a complicated type. So it has a certain name, normal, which is exported by this distributions package, and it does certain things, right? So you can call a function quantile on it, and it gives you back the quantile of that distribution. It's different than other uses of the quantile function, okay? So we're getting very, very ahead, but this is kind of the core of the Julia language, that you have functions that have a certain name that behave differently for different objects.
I see.
Okay. Okay, so let's just solve this. So by the way, I can go up. If I go up with my arrows in the keyboard, it goes to the previous command. Okay, up, down. And what's also nice is if you start typing quantile and then you go up, it does a reverse search on that thing. So it's very quick to find previous commands. Okay, so before I type somewhere print ln, so I just do and I go up one, it immediately finds what I did. Okay. Oh, by the way, cool things in the REPL, you can also do stuff that go over several lines. Okay, so if you do print ln, you can do hi, this goes, and you do shift enter, goes over 2 lines. Then you can do that. Okay, you can also correct it, you can go back up. Okay, whatever. Okay, so it's just it's a nice console that you can go back up and correct stuff in your loop or whatever. You can do things. Okay, so let's solve this. So I went into the quantile function. I know what that is, and now I want to know what is the value of the PDF of that function at that value. Right. So, well, PDF of that particular distribution at that value is this. Okay, 0.2. Fine. What is the CDF? Who knows? You don't need much computing for that, by the way.
0.
No?
No?
No.
95.
Yes, exactly. It's the
Okay.
inverse.
Yeah. Cumulative. Yeah.
Good. It's the inverse, okay? It's just the same thing. Okay, so it seems to work. Julia knows how to compute the CDF. Okay, great. So that's it. Let's do a quick break. 5 minutes. Everybody stand up, stretch your legs a little bit, and then we come back and we do much more fun stuff. Okay, so stay tuned and don't run away. Okay.
Good. Thanks,
5
Florian.
minutes. Bye.
Thanks, Laurie.
Okay, here we're back. Good. So.
Hi, Florian.
So I promised you more fun now. So the bar is high.
Florian, remember that you have some slow students here.
Well, you're still all there, it seems. So that's fine.
Rafa and Luis are too advanced.
No, don't worry. We'll all be there. So okay, so let me do something now. So I created of course, what else would I do? I created a repository with all the material for this, which later on I'll share with you, and you can look at all of this. And now I'll go there. It's in a location called Git on my computer, and it's called bootcamp, isn't it? Julia bootcamp. That's it. And now I'll start Julia from there, as I promised you I would do. And I use a package that I like a lot. It's called Pluto. And what Pluto does, it's a notebook environment. You know, notebooks like Jupyter, and RStudio has Knitter, and there's a bunch of those. So those environments, basically, they're very nice to put together text, code, pictures, and stuff like that. So I mean, they're perfect for teaching, basically. Okay, so I can write text, can even type math and stuff, and then next to that I put the actual code that does what it's supposed to do, and I can put the output next to it and so on. So this, what you see here, is Pluto. We'll talk later on a little bit about it, so no need to do anything now. And I'll open one of those notebooks for us to get started. So what's the one I want to use? First, variables. So that's the first thing we'll do. Right, so I'll open this one. It's gonna load, and then it will come up shortly. So again, so what's happening here is, you see, this is my Julia terminal, and Julia is running here. Okay, so all the computation will be done in this thing. Just it's routed through my browser. I can see it in my browser right here. Okay, so now it's gonna come up. Everything's a bit slow when I'm streaming video and I don't know what. But here we go. So this is Pluto, and this is the first notebook we'll look at. We'll look at a series of those, and we'll just get as far as we get. No problem if we don't make it through all of them. Okay, so while we're waiting, first thing that I should tell you, inside Pluto, so this thing here, the yellow thing, is called a text, a code cell, excuse me. So this is actual code that is being evaluated. So here, what do? We say using Pluto UI, which is a package, using colors, which is another package, using dates, which is still another package, all with different functionality. Okay, you can kind of guess what they're doing. The begin end stuff is there. The begin end creates a block, and I have to do that because in Pluto it expects one command per text box. So if I have more lines, I need to group them together like in a block like that. Okay, it's just an aside for Pluto, but in case you're wondering. Okay, that's it. So I'll get going now. I press the present button, and then this thing will just take off and go totally wild, and I will take it from there. Okay. So first thing we need to obviously learn and do a bit more is how to assign variables and how to do basic mathematical operations. All right. So text screen brush. So we have the equal sign, which assigns values. Okay. Well, for our users, not so obvious anyway, but that's the way it is. Variable names can be anything. Is this too small actually for you? This is a bit bigger. Variable names can be anything. Okay, it doesn't have to be only X, Y, Z, but can be any Unicode character. We'll see later on what that means. So Unicode is a very big set of characters. Strings are going to be in double quotes. Characters can be in single quotes. So just one letter can be in single quotes. We can do LaTeX. Okay, we can write LaTeX, even in has nothing to do with Pluto in the in the terminal. Let me just show that quickly. So if I have a Julia instance here, Julia, I can start typing a backslash and alpha, and then I hit tab, and it's going to switch to an alpha. You see? And so I can do that with everything that is LaTeX. So it's not only alpha and beta. Okay, good. Done that. So here's a couple of examples. And so please keep your Julia open and keep typing this stuff. Okay, just keep trying this out. Okay, the first thing I do here, I say x should be 4. Here in Pluto, by the way, if I click the little play, it's gonna evaluate the cell, or also I can do Shift Enter. So I'll do that, Shift Enter. X is 4. I can do another one. So obviously powers are just the usual power sign. And here I do my alpha. Alpha is 1/3. And I did the alpha as I just showed you. I have a backslash alpha and I hit tab. Beta, 2/3. I can do Boolean operations like standard. I can check whether alpha plus beta is equal to 1. So equal is the Boolean operator checking whether left and right hand side are the same. Okay, now here's a bit more fun stuff. So here I'm defining 3 variables at the same time in one line. Look at that. So there's the variable smiley, the variable dancer, and the variable pizza. And I'm assigning those to the values 1, 2, and 3. What on earth is he talking about? So if I do backslash and I do smile like this, so the colon stuff gives you and I hit tab, gives you an emoticon. You see, I go back to smile and I evaluate smile. What is smile? Smile is 1 because it was a standard value 1. Dancer is 2, pizza is 3. Okay, so just to tell you, this could be anything. These variable names. You can use the smile to compute your functions if you like that. Okay, maybe it's not the best, but you know, there's pretty good examples where they're actually very nice. In epidemiology, I've seen stuff where they use, you know, a little ant symbol to represent the number of ants, little frogs to represent the number of frogs. So it's quite cool. And then you can compute with this. So here's the if-else function again.
So just one
sure.
very quick question. When you define the 3 variables at the same time, it's not that they are in a vector form or anything like that. They are completely independent, or
yes.
Not.
Good question. We'll come to that. What's on the right here is called a tuple. Okay, so it's a very certain kind of a vector, but
what I mean is you can use the smiley as you were using the beta, no?
Exactly right. Exactly right. So they're exactly. So
okay.
They're just exactly.
Okay.
Exactly.
Thanks.
And so that's what I'm doing here, kind of. So I use the function if else as we did before. You remember the if else function has a condition as the first argument. So the condition is smiley plus dancer, is that equal to pizza? If true, return this thing. If false, return that thing. Okay, what is this? Well, you return, if it's true, you return this string. It's a certain kind of string. MD is markdown, so it's a markdown string, just some kind of string, don't worry about it. So if it's true, it's going to print that. Okay, it seems it's true. This is correct. Oh my God. If it's wrong, it's going to print that. Okay, well, how could it be wrong? Well, I could just change this. So let me just change the value of pizza to 5. Oh no, it's totally wrong. Okay, so you can actually do computation with this thing and change. You know, it's just normal variables. That's what I wanted to say. Okay, let's move on. Then you have what is called updating operators. Okay, so this is also kind of common in some languages. You can say x plus equal 1, which is just gonna take x and add 1. You can do the same with all the other 4 arithmetic operators. So this is nice to write concise code. You can also write nice code by leaving out the multiplication symbol. So you can see if you have the number in front of the variable, this is valid code. 5x plus 3 alpha minus 2 beta is valid Julia code. You don't need the multiplication symbol there. It doesn't work if the 2 is after the beta. It has to be before. Okay, so these are just little things that could be useful. Next thing we start talking about is types. All right, we mentioned that already. Each object in Julia has a type, and we already used the function type of, as I do here. So the type of the pizza symbol, what is it? It's an int, because you remember we assigned the number 1 to the pizza symbol. So that's an int. There's obviously strings. So what is the type of cuál es el significado de qué onda, way? It says it's a string. What's a string? Well, a string is just a collection of characters. And so I put this here because you see this is not a standard string. It's an A with an apostrophe on top. Okay, so again, the set of characters is extremely large. So you will never have a problem in Julia that it can't read, I don't know what, an A with an apostrophe on it and a question mark that is on top down. Okay. String, by the way, you can use strings and you can use variables that hold a string and put them into another string. You can kind of build strings, okay? It's called string interpolation, that thing is very useful. So for example, if I have this thing here, I have a variable, there's a beer glass, so 2, beer is equal to 2. I can create this string myself. So here I make a new string with the 2 quotes where I write stuff. So I say, I'll eat. And with the dollar operator, I can grab the value of the variable pizza and evaluate it. Okay, so that goes here. So I'll eat as many numbers as there are in pizza. I'll evaluate that. That was 5. I'll eat 5 pizza and I'll drink, evaluate the value of beer. That's here. Beer is 2. So that goes. And I'll drink 2 beer. And then I can even compute with that. I can say, make that the value of beer plus 1, and that makes 3 beers. Okay. So just to tell you, you can, if you have the dollar operator inside a string, you can evaluate stuff and you can, that's it. You do computation. Okay. Boolean operators. We had that already. Very standard. Equal means is left-hand side equal to right-hand side in a numeric sense. So are they numerically equal? There's short circuit operators, so you can have that's short circuit or, that's wrong. So is left or right true? Okay, the short circuit means it only evaluates, comes from the left, and it only looks, if the first one's true, it stops. It doesn't go and check the second one. That's enough. Okay. And same for and, short circuit and. If the left is true, it goes on. If the left is false, it doesn't even go on because it needs to have both true. Okay, it's just little notation stuff. I think this is very basic and the same in most languages. Okay, now let's finally go to some data types. Okay, we talked about that already. So here are some basic data types. The first one is an int 1. You see the colon thing specifies the type of some input, some value. So if I do 1 : int, it means this is an int, even though Julia obviously knows that if you type 1 without anything else, that it is an int, because you don't have to do that. I just made this here to be very explicit. There's floats, of course, floats that can define not a number, infinity, true, false, we had that. We had characters, you see with 1 quote and strings with 2 quotes. Okay, and then you can convert those. So you can take from one type and convert it to another. For example, if I convert the value 1, which is an int, to a float, I get 1.0. Okay, it's just simple conversion. If I have a float, it's the same thing. You can just call the type on the value, it does exactly that. It converts it to this new type. Convert 2.0 to int, that also works. It knows that it can just chop off the 0.0. Same thing here. So for example, what is that going to do? Convert int 2.1. That doesn't work. Because of course you cannot just chop off the 0.1, right? That wouldn't be correct. So it says it's an inexact error. You cannot do this conversion. Okay, of course you would have to round that somehow or do something that makes more sense. Okay, Good. All right, there's more conversions. A string of a Boolean, or if you convert true to string, it's going to print true. The int of true is 1. Okay. Bool of 1 is true, and so on and so forth. Bool of 2 doesn't exist because it doesn't know. There's just two values, 0 and 1. Question? No.
Sorry, Florian, sorry.
No, go ahead.
No question.
Okay, I see. So the zero function gives you the 0 element of that particular data type. Okay, so it's called the additive identity element. You know what 0 does. If you add 0 to something, you get back something. Okay, you don't do anything. And so that's what this does here. The type of this is float. So you get the 0.0 is the 0 element of the float data type. You can do that with all number types. Okay, so for example, the multiplicative identity is the 1. The 1 of this guy here is, what is this? Let's see what that is. Type of this number, the weird number, is a complex number. You see, it has this imaginary part. Okay, and so this also has a 1 element. So that's this. The 1 element is the multiplicative identity. You multiply with that thing, you get back the same thing. You know what 1 does. Okay, then there's floor, ceil, round. Okay, we talked about rounding. So floor of a number goes down to the next what? That's a good question. It goes down, depends what the number is. But this one goes down to the next, full float. It takes you down to 3. Ceiling takes you up to the next full float, so 4. And the round is going to round to, again, some digits. Okay. You can also specify the data type. So if you say round pi, so you have type pi, round to int. That's not going to work. There's no method that does that. Okay, that was stupid. That doesn't work. Okay, parse. Well, that's very useful. So you can parse a string into an integer or some other data type. Okay. And then you can. So here you see, is that an int? So the isA function is the same as is that type of this thing int. So you can ask parse isA int. It says true. You can have big floats. So big floats, you see, these are huge numbers. They're super long. So in Julia, there's no overflow. You cannot have too big numbers, too many digits. Okay, it doesn't happen. There's arbitrary precision arithmetic. And for example, the big float data type is like 1,000 zeros to the right. So you can have very, very big numbers. Finally, promote. You can promote you can take a float and upgrade it to. No, you have two numbers, so a 1 and a 2.5, where the 1 is an int, and you can promote these numbers to the lowest common denominator. Okay, and you can see that is going to give 1.0 instead of 1. So the lowest common denominator is a float here of those two. Okay.
Florian, what is the parse? This parse?
Well, parse reads some input. And so let's just do something. Let's just bring up this help thing. What's the help of parse? What does it do? Parse a string as a number. Okay, so it's always about reading a string and converting it into a number.
It's the same as the eval in MATLAB?
I don't know that function. Could be. Yes, it sounds familiar. So if eval, what it does is it takes a string and it evaluates it.
Yeah. For example, can I write in a string a command like maximum of 3.5 and parse it, and it will run this as if it was a command? Yeah. Yeah. So exactly. Okay. So that parse function is not that complicated. It doesn't do exactly that. What you said, you can do that. So there is the eval function, Julia. So eval expression. So evaluates an expression in the global scope. So that's pretty much exactly what you just had in MATLAB. Okay, so definitely the main difference here is that expression in Julia is another data type, is not a string. Okay, and so that's another big difference to something like MATLAB.
an expression you can tease apart. So if I write a program in Julia, and this is called an expression, I can then later on go into the expression and, you know, and look at and change it. Okay, so it's much more powerful than a string. Okay, so you know that's music of the future. But basically, if you think about complicated programs where you have to modify certain parts of this graph, you can do that in Julia. For example, automatic differentiation in machine learning uses a lot of that functionality. Okay, and you need a modern language to do that. Okay, strings, some string operations. Okay, we had the string already. S, I assigned it to the variable S. It's going to be the first part of that sentence. Type of S is string. And so there's you can combine strings like this with this multiplication operator. So if I say S times that, it's going to paste them together. It's the full sentence again. Hi there, you can just give two strings to the string function. It's going to put them together. That's the same thing as a multiplication operator. Or you can have the function string and some sort of number, for example. So you would then parse this number and convert it to a string and show you that. Okay. So that's very, very basic stuff. Okay. Now, whenever the green stuff comes up, then you have to do something. And the way we're going to do that is that I'm going to put you now into breakout rooms, which is this very cool Zoom feature. I'm going to create 3 of those. I'm going to assign, you know, so you're going to be in teams of 2 or 3, and you will have to do the task. And when you're back, when you finish, you come back, and you know that's going to be a very short task, but that doesn't matter. In order to be able to do that task, you need to see this thing, right? Otherwise, how would you do it? And so here's now the trick of the whole thing: is what you just saw here runs as a website, and you just open this in your browser. Okay, so it's a URL, it's here when we do the first thing. So let's just grab this and share it to you on the chat. So I want you to open this link. I just put it in the chat. Open that in a browser, and you will be able to go to the first question box, so you can read the question. You put it on the side, and together in your group of 3, you try to do that very simple task. Okay? Okay, good. So let me create those breakout rooms. We'll do it very quickly, yeah? So 2 minutes or 3 minutes, but we'll do it. Breakout rooms. Create 3 breakout rooms, assign automatically. Okay, bye-bye. Oh, you need to join the room now. So you guys need to join the room. Okay, you guys are back.
We managed.
You managed, awesome, fantastic. Congratulations.
Not sure if the best way, but
that's fine. Anyway works. Okay, great.
We're back.
Excellent. Okay, so let me show you the very sophisticated solution to this problem. Okay, so here's my solution. Make this bigger. Okay, so create a string S1, which has the word hello. Create a second string, which has my name. And then use the function println, println to show this. And so basically, so evaluate these strings inside another string. You can use the string function like I did here. So Sn, comma, space, and so on, n, comma, welcome Julia. Or you could have used the dollar operator to make a new string, etc. Let's just see if it works. So if I do, what do? I just do this, execute file in REPL, right? I hit enter. There's something should happen. So it needs to start Julia. It's going to take a little while, but it should print, hello, Florian, welcome to Julia. Okay, awesome. I managed. Fantastic. Okay. Good. So that's it. We'll do a bunch of those, and hopefully you'll enjoy it as much as I do. All right, more strings. There's a bunch of special strings in Julia. For example, in this notebook, I use a lot of markdown strings. I already mentioned those. You write them with, you just do the thing where before the string starts, you have a keyword. And here's MD and then the string. It looks like this, MD string. You can have 3 strings to have multi-line strings, by the way. 3 quotes to have multi-line strings. And so markdown is this. So for those of you who don't know, markdown is like a very simple HTML dialect. It's very much simpler than HTML. And yeah, I recommend you look at it. So look, this is how you do a link in markdown. Markdown, you just do square bracket and then the link afterwards. You know, everybody can do that, even everybody. You don't, you know, if you write a link in HTML, it's much more complicated. So here, this is kind of nice. People use it a lot all over the place. Next, there's raw strings. Raw strings, you just type the word raw in front of the string. And so it's very nice because it doesn't do any escaping or nothing. So it's very nice to write a Windows file path, for example, you see? So it won't touch the backslashes and all of that stuff, which I guess sometimes annoying when working with these paths. Okay, file system. Right, we talked about the file system already a little bit. File paths. Okay, a useful function is the join path function, which is just going to take the bits of your path and put them together into a valid path. So look, if you do that, it says path to file. It's going to use this slash operator because on my OS, you need this slash operator. If you type it, you should type it. You will see it does something different on a Windows machine because your machine has this operator to separate these things. Okay. All right, so that's useful. What's useful is this macro add underscore underscore file underscore underscore that gives you the location of the current file where you're at. So that's where this is on my computer. Same with the directory. Okay, that gives you the directory where the current file is located. You can use in an interactive session, you can use the pwd function. Again, it gives you the current location. And you can, as we said before, you can use the cd function inside Julia to change a directory. Okay, so if I do cd like I do here, dot, I change to the directory dot, where dot is the current directory, so I don't go anywhere. Okay, so that's always safe. I'm going to stay where I am. Okay, so that's some basic file system operations. Next task, here we go. Next task is there for you. So in your browser, just go forward to the next question where it says save the path of the current directory to a variable, etc., etc. And I'm going to stick you into new breakout rooms. All right, see you there. So you have to go. Oh, I need to open those. Sorry. Now you can go there. Okay, you need to join the room, I think. Can you hear me, Caio?
Hey.
Hey, you need to join the breakout room.
Sure, but did you see the, I'll join, but did you see the message that I sent you? The shift enter simply doesn't work in my Mac.
What doesn't work?
The shift enter, I cannot evaluate anything.
Ah, interesting. I didn't know
Yeah.
that. But
And I tried to install and reinstall Julia, install and reinstall VS Code.
You mean like this, when you do this and you do shift enter, doesn't work?
It doesn't work at all. It works on Julia, but it doesn't print anything. It doesn't evaluate anything.
I see. Interesting. So there must be, maybe you have there's a mapping that's wrong. So if you go into the command palette and you type Julia, and when it says execute code in REPL, what do you see there?
Right. Let me check. Execute active code, execute codes in REPL. It says shift option enter.
I see. So you see you have a different shortcut there. So just go to a line of code like I would here. So this line here, and again do that thing. So go to the command palette and just see what it does. So Julia execute code in REPL and move, and just click on it. Forget about the shortcut for now. Click on it and see if it works.
Okay. Let me see. Actually, no.
Okay, it's annoying. So you can't evaluate anything in VS Code. Okay, that's yeah, I don't know why that could be. So you have to just use the console for now. And I mean, I'm sure there's a solution to this, but I can't help you now, unfortunately.
Yeah.
But don't worry, I mean, some Googling and someone will be able to help.
Yeah, I'm trying to
okay.
Google it. But anyways, somehow I'll be able to. I'm following everything.
But you can still do
great. But I just cannot test it.
Yeah, but you can do include, no? So if you do include, that works.
Let me see.
Just include the file. Like if I do include print string, that's the file I created here.
Let me try.
It should work.
Nope.
Doesn't work either. Okay, well, something's really wrong in that sense. Okay.
Yeah.
All right, we'll need to figure that out later. Okay, welcome back, everyone. So, okay, so who managed to do that very difficult task?
I believe I did it.
Okay, Great. So what did I call that?
I think I didn't understand this temp dir. I know that I can see a crazy directory name if I press temp dir in parentheses.
Yes.
But the task, we should go to that directory?
Yes.
Okay. Yeah, what I did, I created a bootcamp in the directory I created in my Julia course folder.
Okay, that's fine.
But I think I got now what you mean.
Okay, so the idea was just that you go to where is the solution of this? Nowhere. Okay, well, so we'll just have to do it like this. Save the path of the current directory into a variable dir. I'll just do it here. Okay, so this is the current path. So I'll do dir is that. Okay, look at make dir and create it. So find out what make dir does. So make dir creates a new directory. Okay, create a new folder in your temp dir. For temp dir, you need to know how you can get the temp dir. So that's that. Temp dir is this. So we need to do make directory. And where do we want to do that? We need to create this path, join path, make dir. And we want to call it bootcamp. Right? There is no method like that. Why is there no method like that?
Maybe you need to use the underline dir.
Yeah, what am I doing? Sorry. Yeah, I did the wrong thing. So I was completely wrong. So where did I save that? Wait a second. Did I not save that? I called it dir. Okay, that was the issue. So I want to create this path that goes dir, and it's gonna do like this. Okay. So that's my path I want to create. So I do make dir on that. Okay. So now that's there. I wanted to create it. Okay, I made a mess myself. So forget about it. So, but I hope you got that. You were supposed to create in the temp dir directory this new folder, go there and go back to where you are just by using the cd operation. I should write a solution on this that makes a little bit more sense. Okay, let's forget about it. It was just a quick exercise to do some cd and some pwd commands.
Florian, this temp dir sounds interesting. It's like there is a path that you can go and
yes, absolutely.
Debug and save things, and then it will disappear.
Yeah, so you can think of it. So each system has this. It's an environment variable. It's so if you look at temp dir, it's going to tell you where it's going to look. You see, there's this list of environment variables which are on each system available, and they're exactly for this purpose. So you can just store stuff there, and that then will get deleted exactly. So it's not a safe location, but you can just dump stuff and get it back.
But this is not Julia, so not only a directory for Julia, no?
No, not at all.
Okay.
For your system, exactly right. Everybody can use it. It's exactly right. It's a free resource, so to speak. Okay, right. What else? There's the contains function. Contains is useful. It tells you whether one string is a substring of a larger string. For example, there are many football clubs in Barcelona, and you want to see whether football is part of that. So contains tells you, yes, that's true. Same with occurs in. Okay, you do it the other way around. Occurs in football in that longer sentence, that's also true. You can use regex. Regex are regular expressions, which are very powerful. So you can do very complex patterns and search for those, and you create them with an R. So that's another string. You see, R in front of the two quotes creates a regex string, a particular type of string. So here I say R should be equal to the regular expression A or B. Okay, and then I'm going to do occurs in A or B in CDE. It says false because neither A nor B occur in CDE. Okay, so that's very basic.
Sorry, can you repeat what is this regex?
Yeah, regex is called regular expression. Is a concept that's very old. It's a computer science concept. You use it to match patterns. Okay, so it's nothing to do with Julia. You can use regex in R and in the shell, wherever. And you can construct, as I said, patterns like this. So this pattern says look for A or B, and then you can match this pattern in different strings. It's a very powerful thing. You just Google regex if you want to know more about this. For us, it's going to be very simple patterns like this one, A or B. Okay. So for example, the next task is going to be to find out what the function find all does. So look at the help for find all, and find all the positions of the character G or smiley. So you can also look for smiley. It's just a regular character in Julia. In the following sentence, the weather is good today. I'm not going to take an umbrella, smiley. Okay, so I want to know in this string, at which position do I find either G or smiley? And well, let's do that one together. Okay, so let's just go a bit quicker. So find in string. Well, let's first look at the help for find all. So what is find all going to do? Find all. What does it do? Oh, for example, here. So the last example, find all A in the string Batman, tells you it is at position 2 and 5. Okay, 2 and 5. Okay, I mean, we can use this example, right? We can just copy this, and instead of A, we'll use our regex. You know, I told you how to do a regex for or. It looks like this. R, you would put G and smiley. All right, let's see how I did it. You do find all the regex of G or smiley, and then you put the string you want to search.
Marian, can I make a question?
Yeah.
So in the editor, if I write /alpha and I press tab, I see alpha. But if I press / colon smile colon tab, the smile doesn't appear. But if I do it in the command line like you're doing, it happens. It works.
Ah, so you say
in the editor it doesn't work.
Ah. I see. Interesting. It's true. I don't know why that is. Huh. I don't know. That's the only way I know how to do it. So I don't know.
Maybe copy from the.
Yeah, you can just copy it there. That works for sure. You can also, most of the time, I go online because I don't know what these things are called, and you can just copy it into the thing. Anyway, that's a solution. You see, find all the pattern and the string, and you will evaluate that now. So shift enter, and it gives back this. Well, we can't see it. So we need to do it again. My screen is too small. So it gives back this vector of ranges. So 16, 16 means from 16 to 16. So the element 16, 16th element here is this G. So 36 is going to be here, 40 is here, and so on. And 62 is the last one. That's that position. Okay. Of course, also the blank. The blank is a character, so the blank counts as something. Okay, good. So we can close that. Don't save. Let's see what we still can do before the lunch break. So occurs in, we can also do the regex as occurs in. That's fine. So that's our regex A or B. You remember. So the A team A or B occurs true. We can use the match function, which is going to find the first match. So match regex in the A team, because there's more than one A's. You see there's A team and there's A's. So it's going to have to choose. Or you can find each match. Each match is going to find, you see, it gives back a regex match iterator. It gives you back all the matches. No, you don't see it here, but it does that. And then you can, oh wow, look at what this is going to do. You can iterate over this and create an array. Okay, so you see, it's going to tell you what are all of these matches. Well, it's the first A that's here, it's the second A that's there, and it's B, which is there because the regex said A or B. Okay, and I can get those all with this thing. Now that's a crazy thing, right? What is this? This creates an array. And so we'll now we go for lunch. Now we relax a little bit. And after lunch, we will learn what exactly that is on Earth. I'll just tell you it's an array, okay? It's an array, it has 3 elements in it. But in general, we call this thing a collection. It has, you know, several elements in it and we can do stuff with it. The way we created it with this square bracket here is called a comprehension, just one way to create arrays. And we'll learn how to do all of that. Can you imagine how cool that is? And so, yeah, so I think we should stop now. It's going to be 12 in 2 minutes. And we'll continue here at 2 o'clock. Any questions?
Yeah, very quickly,
Sure.
because you said something before about these very big numbers that Julia doesn't have any overhead. Yeah. And you said something that there is arbitrary precision. What does that exactly mean? Is it that the language doesn't slow down because of a large memory, or is it something about really the precision of the numbers that it can store?
Yes, no, it's exactly about the precision. So traditionally, all languages have an upper bound of what they can represent, right? You have, and then basically the number of digits that you can put into a number. Yeah. If you think of a float, just think of how many numbers after the dot can you put. Okay, so this usually they're already very big, those numbers, but you know, anyway, if you have a computation that uses very big numbers, which may as well happen, you can run into problems that are called overflow, which basically means that you will have a number that's, so take the biggest number in your computer. So let me just do that. So in Julia, there's a function called type max, which gives you the max of a certain numeric type. So let me take the type max of float 64. Right. The type max of float is by definition infinity. So okay, it's a bit weird, but because of course if you do this plus 1, you get infinity, but that's fine. You could also define that. The point I wanted to make is you don't run into trouble here. You can, in Julia, you can always go further than the maximum of the type, you know, so you don't fall off the cliff of the highest number. So there's no overflow in this language. If you have a very big number, you can just use it. Okay, this has nothing to do with performance. It has to do with precision. Okay.
Okay, but does that also involve about, for example, problems when you are dividing large numbers by very small numbers? Because, for example, I mean, if you divide 1 by the machine epsilon, you will be doing weird stuff. If you, for example, you want to compute an inverse matrix or something like that.
Yes.
That doesn't happen in Julia, or?
Well, so so there it's like the other end of the type space. It's the smallest number. That's kind of the tricky thing. So that you won't get around that. So the smallest number is what it is. So that's epsilon.
Okay, so then if you divide 1 by the biggest possible number, you will get the machine epsilon or whatever. That,
yes. Yes. So you won't get around that. It's just you're able to represent very, very big numbers.
Okay.
When otherwise in other language you are limited in this.
Okay. Because I misunderstood a little bit.
Yes.
Okay. Thank you.
Sorry, since we're talking about this, a related question.
Yeah.
You wrote alpha at some point. You wrote alpha is equal to 1/3, and then beta is equal to 2/3, and then you asked if alpha plus beta is equal to 1.
Yeah.
What are those variable types? They are floats.
Which variable types? The alpha.
The alpha and the beta and the 1 that you're using in the logical expression.
Good question. So when I do 1/3, we just ask it what it is, right? The type of that is a float. Okay. But you correctly said if I do 1/3 plus 2/3 gives exactly 1. So it's a very long float. So it represented as exactly right. But what's more interesting is we can create an actual rational number with 2 backslashes. Okay, so that number represents exactly 1/3. So if I do 1/3 plus 2/3, it gives exactly 1, as the mathematical definition of a rational would tell you, right? So it's a different number type. If you want to work with rationals, with fractions, you can use that. Okay. You can ask whether this is exactly equal to 1. So that's true. Okay, so it has a way to represent that to an extremely high accuracy, the 1/3. And so I guess you're worried that the 1/3 is 1.33333, right?
Yeah. Yes. Exactly.
So you can stop here and you do 1.666, then you won't get that. Okay, so you're right that it by default it just represents a very, 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 very big line of zeros here. Okay, it's not exactly eagle. We'll talk about that later on. So that if you do 3 equals, it looks if it's the same object, not only if it's numerically equal. So we are interested about numerically equal. Okay. Okay, so let's continue at 2 o'clock if there's no more questions. Right.
Thank you.
All right. See you later.
Hi, Florian. Thanks.
See you.
See you.
I'll just start this thing again. Okay, I'll shut it down now and then just save some electricity.
Hi, Florian.
Bye.